Hello, this video is for the semester 2 review packet for the final, and it is the factoring section. So this is on the front page, and it would be questions 1 through 6. Feel free to skip ahead to the questions that you just need to see answers to. Feel free to watch the whole video if you want to. So question 1 said, write the factored form of the polynomial modeled by each geometric area diagram. So these are the boxes that we use to help us factor things. The box is already filled in for you, so really you just need to work the box backwards to figure out what your two binomials would be. So like to get my x squared, I would know I need an x times an x. And then to get this 5x right there, I know I'd have to take this x right there times a positive 5. And then to get that single x right down here, I know I have to take this x and multiply by a positive 1. So my overall binomials then would be x plus 5 and x plus 1. Work the next one out doing the same thing. You should have gotten x plus 4 and x plus 3. And then looking at our last one, that one's a little bit different. For the 3x squared, I know I could do 3x times x, but I have to think about where I want to put my 3x and my x. So for example, if I put the 3x here to get started, I know I have to multiply this 3x by something up top here to get this x. Well, I can't multiply 3x by a whole number to get just an x, so I know that my 3x can't go there. So checked it, tried it, didn't work. That means the 3x needs to go here. I have to multiply that 3x by a 4 to get that 12x. That means x has to go here, which I have to multiply by a 1 to get 1x there. So my two binomials are 3x plus 1 and x plus 4. Alright, question 2 said, what is the GCF, or greatest common factor, for each set of monomials? So you're not actually factoring here. You're just asking yourself, what's the biggest thing I can take out of all of them? The biggest thing that they all share. So when I look at these, I first start with the numbers. So what's the biggest number they share? And then I move on to the variables. So in A, that x cubed y, well, there's really just a 1 in front there. The next monomial is 2x to the 5th y to the 5th. So the number there is a 2, and then 4x squared y cubed. Biggest number they all share is a 1. And then I have an x cubed, an x to the 5th, and an x squared. I have to go with the smallest number of x's, which is an x squared. And that's because, for example, this guy has an x squared, only an x squared. So like I can't do the x to the 5th as my GCF because the x squared doesn't have enough x's to match that. Okay? And then I have a y to the 5th, and a y cubed. So my GCF would be 1x squared y. Looking at my next one, 2a, 4ab, and 6abc. Greatest common factor for just the numbers would be I can take a 2 out of everything. I can take 1a from all of those. And then I can't take a b or a c because that first guy doesn't have a b or a c and the second guy doesn't have a c. So that would be my greatest common factor for the middle one. For the end one, for the 12v squared, 24v cubed, and 30v to the 4th, biggest factor just number-wise that they all share would be a 6. So since 6 goes into 12, 24, and 30, and then I have the choice between v squared, v cubed, and v to the 4th. The most v's I can pull from each of them is a v squared. Alright, so the next couple slides are for, alright, this slide is just question 3, so factor completely. All of these problems here, the first two are binomials. So with a binomial, I'm checking for two things. I'm checking for greatest common factor, and then I'm checking for dots. So if I look at this first example here, 2x to the 2nd, y plus 14y cubed, biggest number I can take out is a 2. And then I can also take out 1y. So then I would divide this all by that 2y. So that would leave me with x squared plus 7y squared. And that would be the factored form, final answer, because x squared plus 7y squared is not dots. If I'm looking at B, 12m to the 5th plus 3m squared. I'm going to write that a little lower. Biggest number they share would be 3m squared. Since they can take a 3 out of each and I can take an m squared, so then I'm going to divide it by 3m squared. 12 divided by 3 gives me 4, and then m to the 5th over m squared is m cubed. And then 3m squared over 3m squared, well, I'm dividing it by itself, so that leaves me with plus 1. Last one is a trinomial, but because of that cubed on my last term there, I'm not going to factor using diamond and box. I'm just going to look for a GCF to begin with. Biggest thing I can take out for a number is 5. And then because this middle term here doesn't have a c, I can't take any c's out. So I'm going to start with just that 5. That leaves me with 3c squared plus 5 minus 7c cubed. And then we don't factor with cubes yet with that power of 3, so this would be my final answer. Alright, question 4 is the one with a bunch of different trinomials to factor. So for these ones, I'll be doing all diamond and box if possible, unless it's a special case. So remember, you can use the diamond and box setup if it works for you. If you don't need it or you have a different strategy, that's totally fine. So if I'm going to set up my diamond here, I know I'm looking for something that multiplies to give me 40a squared, but adds to give me 13a. Well, that would be 5a and 8a. I then use that to fill in my box. So then I have my a squared here, my 40 here. So that came from my original trinomial. And then I fill the rest in with the 5a and the 8a. And then I work that backwards. So when I do that, I would get a times a for my a squared, and then this has to be a plus 5, and that's a plus 8. So my binomials are a plus 5 times a plus 8. Final answer. Alright, when I look at B, okay, right away, I have a flag. There's two terms. It's a binomial. So remember, binomial, I'm checking for GCF, and I'm checking for dots. B squared minus 100, biggest thing I can take out is a 1. Doesn't change anything, so I'm done with the GCF. So next I'm checking for dots. Remember for dots that there's a few things we're checking for. First thing is that it's subtraction between your two terms, which in this case it passes that first check. The second thing we're checking for is that each of these terms is a perfect square. So can I multiply something by itself to get that term? So like b squared works because I can do b times b, and 100 is 10 times 10. So this is in fact dots. So remember, with dots, you have the same thing in each binomial, so it's a b and a 10, but one is a plus and one is a minus. So my final answer here would be b plus 10 and b, oops, that's kind of hard to read, I'm sorry, it should be b minus 10 in this second one. Alright, looking at C, I would do diamond and box again. I'll do it for this example. I'm not going to do it for every single one, but I put 25c squared up top. So remember, you're multiplying the first term and the last term to get that, and then the negative 10c in the bottom. So what multiplies to give me 25c squared, but adds to give me a negative 10c? Well, I know I'm looking for two negatives, so negative 5c and negative 5c. Use that to work my box. So I'd have my c squared, 25, negative 5c, and negative 5c. Work that backwards, c and c, minus 5 minus 5. So here my two binomials are the same, so I can simplify it to a c minus 5 squared. If you remember, this is an example of a perfect square trinomial where the binomials are the same. Alright, D is a regular trinomial, so I would set up diamond and box, and I would factor it. Your two binomials when you finish should be d minus 7 and d plus 2. For E, again, same thing, it's a regular trinomial. I'm going to set up diamond and box. After you've done that, check your work. Your answer should be E plus 12 and E minus 2. Same for F, regular trinomial, should be F plus 3 and F minus 2. All right, I'm going to set up diamond and box for G. If you notice, your A term out front is now no longer 1, it's a 2. So I want to check for GCF first. This one I can't take anything out. That 13 here is prime. So no GCF, so next I would go to diamond and box. So here, remember, you're multiplying your first term and your last term to give me 30G squared here, and then 13G. That would have to be 10G and 3G. And then I would work my box. So I have 2G squared, 15, 10G, and 3G. So now I'm trying to think about with my 2G squared, I have to have a 2G somewhere and a G. I'm going to put my G here and my 2G here. Since 2G I can multiply by this 5 to get the 10G, and G I can multiply by 3 to get that single, oops, that should be 3G. So then my final answer should be 2G plus 3 and G plus 5. Okay, looking at H, it's a binomial, so I know I can't use diamond and box, so I'm checking for a GCF. Well, there's a 1 in there, so I know I can't take anything out. So now I'm checking for dots. So remember, first thing is there subtraction between the two terms? Yes, it passes that test. Next thing I'm asking myself is for that 4h to the 6, can I multiply something by itself to get that? Well, to get 4, I could do 2 times 2. And then for the h to the 6, I could have an h cubed. So it would have to be 2h cubed times 2h cubed. So that does work. And then can I multiply something by itself to get 1? Well, that would be 1 times 1. So in my binomials, then, I would have 2h cubed plus 1 multiplied by 2h cubed minus 1. So that was an example of dots, maybe a little bit harder to recognize. All right, last example, 5k squared plus 9k minus 2. Let's set up our diamond, negative 10k squared, and then we have a 9k there. So what can multiply to give you negative 10k squared but add to give you 9k? That'd have to be 10k and negative 1k. Then I would set up my box, getting a little squished here. So I'd have 5k squared, negative 2, should be a negative there, negative 1k, and 10k. Well, to get 5k squared, I have to do 5k times k. That's the only thing that'll work. I'm going to put the 5k here and the k here. The 5k I can multiply by this 2 to get that 10k, and that individual k can multiply by a negative 1 to get negative 1k. So binomials here are 5k minus 1 and k plus 2. All right, for which of the following polynomials is x minus 1 a factor? So here, the easiest way to do this problem is just to factor each one and then to see if any of them have x minus 1 as a factor. The first two, a and b, are both regular trinomials, so I just did diamond and box. When I did that, for a I got x minus 2 and x plus 1. X minus 1 is not a factor for that. For b, when I factored it, I got x plus 8 and x minus 1, so x minus 1 was a factor. C looks a little bit different. It's a binomial. So again, first thing you should ask yourself, can I take out a GCF? Which I can. So I took out an x, and then I was left with x squared minus 1. So then I had to stop myself and say, okay, this x out here is already factored, but can I factor what's inside the parentheses? And I can. It's actually dots. So when I do that, oops, let's erase that, I was left with x, and then x plus 1, and x minus 1. So it was also a factor for C. All right, number 6, last one for this section. If the area of a square is represented by the expression x squared minus 2x plus 1, what is an expression for the perimeter of the square? I like to set up an actual picture here, so I know I have a square. Okay. I also know that the area of this square is x squared minus 2x plus 1. That was given to us. So the nice thing is I can figure out what each side length is, because I know I have to multiply like length times width to get area. So I can figure out the length and the width from this trinomial here. So if I factor that trinomial using diamond and box, you can see that the area is really equal to x minus 1 squared. It's a perfect square trinomial, which makes sense because it's a square, so each side should be the same. So they're both an x minus 1. So now you have a couple options for getting perimeter. Perimeter is just the distance around the outside. So one option, knowing this is a square, is to say, well, there's 4 sides on a square. So to get my perimeter, I can take 4 and multiply it by one side length, since each side is the same. Distribute the 4 through and I get 4x minus 4. That's one way. If you don't like that, since this is a square, I know that this side is also x minus 1, this is also x minus 1, and then you know with perimeter you're going to add those all up. So I would do x plus x plus x plus x, well that's 4x. Add up all my negative 1s, negative 1 minus 1 minus 1 minus 1 is also minus 4. So these two are identical, two different ways to get it. If you have any other questions still from this section, please email me or come see me after school so we can help work through them. Thanks for watching!